Hello everyone. Today we're going to learn about scientific notation. It's really important that you understand about not only how to change a number in a scientific notation, but even how to get it out of scientific notation. Okay. So as you see in here, scientific notation, it deals with very large numbers, very small numbers. As you see, the mass of a gold atom, very, very, very tiny, or the grams of a hydrogen atom, very, very big. Obviously, we would never write this many zeros ever. I mean, it would take you probably about 30 seconds to write all these zeros down. So why write all the zeros down when you can change a decimal number into scientific notation? Okay, so we're going to look at first the rules on how to do it, and then we'll do some examples too. Okay, so in scientific notation, you usually have a number in the beginning. Okay, I just called it the A number, and that A number is usually called the coefficient. Now, some websites will actually say that A number has to be between 1 and 10, and that's actually incorrect. It has to be a number between 1 and 9.9, okay? And I'll show you why not the number 10. So in the front of a scientific notation, that number, just any number between 1 and 9.9. And then you have this little x and times a 10 factor to some power. So the little n is an exponent, an integer. It could be positive or it could be negative, okay? So if I had this number, 4,500, so in scientific notation, it'll look like this, 4.5 times 10 to the third. So the coefficient would be the beginning number, 4.5, and then the coefficient, like I said, just has to be a number less than 10, so 1 and 9.9, which it is. And then the power of 10, the exponent, would be that 3. So the exponent indicates how many times the coefficient must be multiplied by a power of 10, okay? So here's a couple rules to help you. So when you see a decimal number or a whole number, move the decimal to the right as soon as you get to the very first non-zero number, okay? You're going to count how many places you move that decimal, and if you move it to the left or the right, it actually does mean something, as in positive versus negative with that exponent. So some rules that I've come to in the past, if the decimal had to be moved to the right, then the exponent is negative. If the decimal had to be moved to the left, then the exponent is positive, okay? If I take this number, okay, so here's an example. Let's work it out together. If I take all these zeros, okay, and then 902. And if I want to move the decimal to however many times as I moved it, between a number 1 and 9.9. So I'm going to take this decimal right here, and I'm just going to keep moving it every time, but in between. Okay, so there's a decimal right there, 1, and then 2, and then 3, 4, 5, 6, 7, and 8. Okay, sorry, it's not coming up here. So I moved it 8 times. Okay, and I'm going to put that decimal right there. Oops, sorry. That decimal right there, 9.02. Okay, and then how many places did I actually move it? Well, every time you move it, it's a factor of 10. So let me count one more time. So 1, 2, 3, 4, 5, 6, 7, 8. And I moved it 8 times. Okay. So when the number is less than 1, the exponent is negative, okay? So when I write this in scientific notation, 9.02 times 10 to the negative 8, okay? So I'm going to double check my work. I have a coefficient of a number between 1 and 9.9, which I do, and then I wrote my times 10, and then my exponent, I moved the decimal 8 times, and because I moved it in the right direction, that means my exponent is negative, okay? So as you see right there with the answers. So let's try one again together. So I'm going to write the number 28,750.9. Now, if I have a decimal, I'm going to start where that decimal is, okay? If you don't have a decimal, then you start at the end of the number, okay? So I'm going to start right here, and I'm going to move it in between each one. Move it in between each one. So 1, and then move it between this number. Sorry about that. 2, and 3, and 4. So that's where I'm going to end up with my decimal. So I'm going to end up with a number 2 point something. As long as it's between 1 and 9.9, you're fine. But you do have to write down all of these numbers because they do matter. They're what's called significant, okay? And you know we'll get to that topic. So 2.87509 and then times 10. Now I moved it 1, 2, 3, and 4. So I did move it 4 places, okay? And because I moved it to the left, my exponent will be positive, okay? So 2.87509 times 10 to the 4th, okay? So what happens if you see numbers in scientific notation, but they're not in proper scientific notation? So I put a couple of these examples down because sometimes I have students that have trouble not moving the decimal, but trying to figure out how many more places to move the decimal. So if I have 234, well, I know that coefficient's not correct because it's not a number between 1 and 9.9. Okay, so I'm going to move this decimal not only one place, but I'm going to move it a second place. So I can get to a number that's 2.346. Now, I already have this in scientific notation, times 10 to the 9th, but I moved it 2 more places, making this exponent change from 9 to 11. Okay, so 2.346 times 10 to the 11. Okay. What if I move the decimal the other way, to the right? So I'm going to move this one place. Now I know I'm not done because I have 0.6 and I need it to be at least 1. So I'm going to move it one more. So 6.42. So now I have a coefficient between 1 and 9. And then times 10. Now I already had it to the 4th. Okay. So basically when I move it to the right, I'm making it more negative, okay? So this 4 is going to change not to 6, okay? But because we moved it to the right, you're making it more negative. So it's going to change to the 2, okay? 532, okay? I need it to be between 1 and 9. I'm going to move this decimal one place. Now I have 53, and I'm going to move it one more place so I can get at least to 5. So I'm going to have 5.3142 times 10, and I moved it to the left. I'm making it more positive. So I moved it 2 places, so this 5 is going to change to a 7. Okay? So anytime you're doing proper scientific notation, you want to make sure that you move this decimal. Every time you move it, you're moving a factor of 10. Okay, so that's what this times 10 to the 7 means, that this decimal has been moved 7 times. Not that you have 7 zeros, but you've moved it 7 times. Okay, because it does make a difference. If you have 5.3 versus 53, I mean, you're off by a factor of 10. So that's why it's called times 10 to some power. Okay. Here's a couple examples. Okay, if you want to push pause, try them out first, and then unpause so that way you can see the answers. Okay, so I'm going to take all of these numbers and I'm going to make it into scientific notation, and you want to maintain the sig figs. Now, I haven't shown you the video yet for sig figs, or if you have seen the video for sig figs first, you would know that sig figs are very important in chemistry. Okay, so sig figs have to do with these non-zero integers, but also sometimes zero counts. Okay, so right here, okay, I have what's called 4 sig figs, so I want to make sure when I move the decimal, I keep at least 4 sig figs. What happens though if you don't have to move the decimal? So I have a number 5.2, and that's in my formula between 1 and 9.9. So I don't need to move it. But you still have to make it into scientific notation. So 5.280, if you don't move the decimal, then you don't move the decimal. So it becomes times 10 to the 0. Okay, because 10 to the 0 means 1. So 5.280 times 10 to the 0 is still the same number, 5.280. 2,000, I don't have a decimal. So if you don't ever have a decimal, you start your decimal at the end. But I want to make sure that you understand that this is only 1 sig fig, so I'm just going to keep track of that, 1 sig fig, because when you move decimals, sometimes those zeros can count. And I don't want these zeros to count because they're not significant. So I'm going to start my decimal down here and move it 1, 2, and 3, so I can get to a number that's 2 point something. So I got 2, times, I moved it 3 places. Now, because I moved it to the left, my exponent is positive, okay? And like I said, these zeros were not significant, so I'm not going to put those zeros with it. So 2 times 10 to the third. For 15, I just need to move that decimal, looks like 1 place, and I don't have a decimal, so I'm going to start it at the end. So 15 is now going to turn into 1.5. So 1.5, and I moved it 1 place to the left, so my exponent will stay positive. And 15 is 2 significant figures, and I still have 2 significant figures. 6,589,000. I only see 4 sig figs, so I'm going to keep the 4. These zeros are not significant because there is no decimal. So I'm going to start my decimal at the end, and I'm going to move that decimal 1, 2, 3. And when I learned this way back in the day, my teacher called these waves. Okay, some teachers call them cradles. You're just basically moving the decimal in between every digit. Okay, so I moved it 6 places. So 6.589, and that 589 is significant. So we need to make sure we write all those numbers, but not the zeros. They're not significant. So 6.589 times 10, and I moved it 6 places, and I moved it to the positive. 0.00263. That obviously I need to move the decimal not only 1 place, but I need to move it 2 places and move it a 3rd place. So I can get to a number at least 2 point something. So 2.63, and these zeros are not significant. Okay, so they're what's called placeholders. So we don't need to start this number with 0, 0. I've seen this before with students where they do it like this, and it's like there's no point to write those zeros because they're not significant. So please move the decimal 3 places, and because I moved it to the right, my exponent is negative. So 2.63 times 10 to the negative 3rd. Over here, letter F, I have a number 2,560. I don't have a decimal, so I'm going to start it at the end. So 1, 2, and 3. So I'm going to get 2.56. And this 0 was not significant because there was no decimal, so I'm just going to keep my 3 sig figs. And I moved it 3 places to the left, which means positive 3. 0.0009, these zeros are not significant, but I still have to move my decimal between them. So 1, 2, and 3, but I need to move it 1 more place because I have 0.9 right now. I need my coefficient to be a number between 1 and 9.9. So I'm going to move it 1 more place, so I have exactly 9. And then times 10, 1, 2, 3, 4. And because I moved it to the right, my exponent will be negative. So 9 times 10 to the negative 4. 8,900,000, no decimal, so I started at the end, and I move it in between every digit. Now those zeros are not significant, but they are an actual digit, so you still have to move it in between it. So I'm going to get 8.9, and those zeros aren't significant, times 10, and I moved it 6 places. And I moved it to the left, which means it's positive. 0.0920, I'm going to move my decimal in the beginning. I'm going to move at least 1 place, and I have 0.9. So I got to move it 1 more to get 9.2. So 9.2. Now, when you learn about significant figures, this 0 at the end is significant. So I do have to write that 0 as a sig fig. The 0 on the front doesn't count because it's a placeholder. So 9.20, and I moved my decimal, looks like 1, 2 places, but to the left, which means negative. And 0.90, just a quick little 1 place move, but the 0 at the end is significant. So 9.0 times 10, and when you move that 1 place right there, and I did move it to the right, so it is going to be negative. Okay, so hopefully you did those correctly, and if you have any questions, just keep watching the video and just keep practicing. Another way I've seen questions also, whereas what if you have it in decimal form, but you have to write it out of scientific notation, so you got to put it in decimal form. So 1.8 times 10 to the negative 4, and that means that this moves 4 times, not that I have 4 zeros. Okay, So this -4, I got to move this decimal 4 places, and I'm going to be moving it to the left. Now, before you ask, like, wait a minute, you said if it moves to the right, negative. But that's when you're putting it in scientific notation. When you're getting it out of scientific notation, it's the opposite. So I'm going to start my decimal right there and move it 1. Now, I don't have any numbers in front of here, so I'm going to be adding some zeros. So I moved it 1, and then 2, 3, 4. And that's where I'm going to end my 0. There's no point to put a 0 in the front of that decimal. You can, but it doesn't mean anything. But these zeros do matter because they're placeholders, but not significant. So 1.8 to the -4 will become 00018. And like I said, you don't have to put that 0 in the front. You can even just put 0.0018. Okay? So let's try just a couple of these. So if you do have these significant figures, scientific notation, and you need to get them out of scientific notation into decimal form. So 4.9, and I need to move the decimal 2 places, okay? And I'm going to move these 2 to the right because I'm getting it out of scientific notation. So 4.9, and I'm going to move it 2 places, 1, 2, and I'm going to fill that in with the 0. Now 4.9 was 2 sig figs, so the question is, do I put that decimal there or do I not? And you don't, because 4.9 was 2 significant figures. Keep my answer in 2 significant figures. 3.75 times 10 to the -2, I'm also going to move this 2 places, but now I'm going to move it to the left so I can get it out of scientific notation. So 3.75, I'm going to move it 1 and 2, and I'm going to add a 0 right there, so that way I need that placeholder. So 0.0375 would be my final answer. And 375 is 3 sig figs. That 0 doesn't count as a sig fig, but it is important as a placeholder. 5.95 times 10 to the -4. Okay? And because it's -4, that means it's a small number. So I'm going to be moving this decimal to the left. So 1, 2, 3, and 4. And in between these little waves, we're just going to add some zeros. Now they're not significant, but they are important as a placeholder. They give value to the number, just not in chemistry called significant. 3.87 to the first, well, it's just a simple little move, and I'm going to move it just 1 place to the right. So I'm going to get not 3.8, but I'm going to get 38.7. Okay? And no need to add any zeros or anything like that because we didn't need to add any zeros. And as we said before, 7.10 to the 0, well, that just means I'm not going to move it any place. So I'm still going to get that 7.10. Okay? So in this video, we showed you how to not only write a number in scientific notation, but how to get it out of scientific notation. So in another video coming up, I'm going to teach you how to do calculations with scientific notation. Hopefully this helped, and see you next time.